Good morning, everyone.
Good morning, sir.
Good
Is
morning, sir.
it all?
Yes, sir.
Okay, 39, 40 students are joined. We will start. Yesterday, in this chapter, halogen derivatives of alkanes, we discuss about the classification of halogen derivatives. What is meant by monohalogen, dihalogen derivatives, then trihalogen. That is included in the polyhalogen derivatives. If more than one hydrogen atoms are replaced with halogens, it is called as polyhalogen derivatives, in which dihalogen derivatives are there. Then trihalogen derivatives, if three hydrogens are replaced with three halogens, it is called as trihalogen derivatives. Then tetrahalogen derivatives. Then the second part of the classification is also completed. That is, halogen is attached to the sp3 hybridized carbon, then sp2 hybridized carbon, and sp hybridized carbon. Primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. So all this part is completed yesterday. Please go through it. Already notes are sent to you. No any question will be asked on this classification, remember, for the board examination. Now this nomenclature system also we studied in the 11th standard. Just I will take 2-3 examples and I will proceed. Say here CH2Cl2. Actually this is a methane CH4, in which two hydrogens are replaced with two halogens. See, the IUPAC name is dichloromethane. The common name is methylene chloride. Also, it is also called as methylene dichloride. Remember, methylene chloride is also okay. Methylene dichloride. Sometimes it is also written methylene dichloride, in which two hydrogens are replaced with two chlorines. Then here see the parent molecule is ethane, in which one hydrogen is replaced with halogen bromine. So the common name is ethyl bromide and IUPAC name is bromoethane. Just like it is isopropyl chloride, then isobutyl bromide, tertiary butyl chloride, we can draw the structures. Neopentyl, in which five carbons are there. Neo means on the second carbon, two CH3 groups are there. This is vinyl chloride. See, vinyl chloride means this chlorine is directly attached to the sp2 hybridized carbon. This is vinyl chloride. And if you see the IUPAC name, in case of alkenes, we give the number to the double bonded carbon. So it will be the carbon number 1, it will be the carbon number 2, it will be 1 chloroethene. Why it is ethene? Because carbon-carbon double bond is there. So that's why the name is 1 chloroethene. To the carbon number 1, chlorine is attached. Like this is a 3 bromopropene. Why this is 3 bromopropene? Because this will be carbon number 1. This will be carbon number 1, this will be carbon number 2, and this will be carbon number 3. The name will be 3 bromopropene. Just like I am coming to the aromatic system, this is benzyl iodide. See, CH2I means here iodine is attached to the sp3 hybridized carbon, and this carbon is attached to the sp2 hybridized carbon. This is benzyl iodide. IUPAC name is iodophenyl methane. Then this is a 1,3 position. The common name is meta dichlorobenzene or 1,3 dichlorobenzene. And then this is para iodotoluene, because this CH3 is directly attached here to benzene ring. It is toluene, and at the para position means 1,4 position. If this is considered as 1, because this is a functional group, special group is attached. Like NO2, it is attached, it is called as nitrobenzene. If NH2 is there, it is aniline. Then OH is there, it is phenol. Like this, CH3, when it is attached to the benzene ring, it is called as toluene. And at the para position or number 4 position, iodine is there. So the name is para iodotoluene. And see, the IUPAC name is 1 iodo. If this is considered as iodo IUPAC, according to the alphabetical order, iodine comes first. That's why it is 1 iodo 4 methyl benzene, or 4-iodotoluene. If this is considered as toluene, it will be number 4. But if this group is considered as methyl, and if this group considered as iodine, iodine comes first alphabetically. So that's why 1-iodo 4-methyl benzene. The some common names and IUPAC. This is also not asked for the board examination. Remember, this is for your knowledge purpose only. How the IUPAC names are given to the halogen derivatives. Then this is homework. Today's homework. You have to solve this homework in your notebook. Write the structures. We have to draw the structure 2-iodo 3-methyl pentane. This is very easy. If you have any doubt, then you can call me or WhatsApp me. This is one solved example is given. Draw the structures of all the 8 structural isomers. We have to draw the structure of 8 structural isomers that have the molecular formula is given C5H11Br. First, we have to prepare the different isomers. So these are the answers are also given. These are the 8 different isomers, and this is the IUPAC name of each isomer it is given. This is for homework. For the which purpose? Whatever the nomenclature system you understand or not, it will be confirmed by this exercise. So also no any question will be asked for the board examination on this part. On this part, remember, this can be asked for the examination any one structure. Write the structure of the following. It may be included in the section A, question number 2. VSA, very short answer type of question. It can be asked. Write the structures. आवाज येतोय का क्लिअर?
हो सर.
हा
Yes, sir.
ओके. याच्यावरती कुठलाही प्रश्न येत नाही खालच्या पाठवर. वरच्या पाठवर एखादा येऊ शकतो 1 मार्काला. दिस इज फॉर नॉलेज ओनली. Then this write the IUPAC names of the following. This is also solved question. Anyone can tell me the name of this compound? I will help you. Anyone can tell me the name of this compound? This is not alkane, this is alkene, remember. So in case of alkene, we have to start the numbering from double bond. So it will be carbon number 1, it will be carbon number 2, or it will be carbon number 3.
Sir,
Huh.
1,3 sorry 1 bromo
1 ब्रोमो कसं काय येईल? 3 ब्रोमो ना.
sorry 3 bromo 1,3
डाय
methyl
Methyl propane.
dimethyl
ठीक आहे. 3 ब्रोमो काय
propene.
प्रोपीन. बघा बरोबर आहे का? खाली नाव दिलेले तुम्ही. काय चुकलं आपलं? 1 2 3 4. हा बरोबर आहे. ह्याला 4 नंबर येईल ना कार्बन नंबर. इथे एक चौथा आहे नाही काय? दिसला का? इथे चौथा कार्बन आहे. 4 नंबरला कुठे? 4 ब्रोमो 1 2 3.
सर आपने पेरेंट नेम गलत माना है.
हाँ एक मिनट.
और फर्स्ट कार्बन को फर्स्ट नंबर आना चाहिए.
हाँ इधर चाहिए. सॉरी. इधर नंबर 1 चाहिए.
तर
1.
डबल बॉन्ड तर फर्स्ट यायला ना पण फर्स्ट कार्बनला.
तेच ना, मग इथे नंबर 1 येईल ना, इथे नंबर 2 येईल,
हा
इथे
ओके
नंबर 3
सर.
कळलं
हा
का? इथे नंबर 4.
हा येस सर.
हा एक मिनिट मी इरेज करून परत लिहितो. हा सी दिस विल बी नंबर 1, दिस विल बी नंबर 2, this will be number 3, and this will be number 4. On the 4th carbon, 1 methyl group is there and bromine is also there. So the name will be 4-bromo, correct? Why it is pent? Because total number of carbons are 5 carbons here in the chain. Total number of carbons in the parent chains are 5 carbons, and why it is 2Ne on the second carbon, there is a carbon-carbon double bond. So the name is 4-bromo pent 2-ene. Then see the second example. In the second example, there is no carbon, see, no methyl group. So it will be number 1 here. Then it will be number 2, it will be number 3, and this carbon will be number 4. So name here it will be 3 bromo, because on the third carbon bromine is there. 3 bromo 2 methyl, on the second carbon this methyl group is there, 2 methyl but 1 in. Why it is but? Because total number of carbons are 4, and on the first carbon double bond is there. So the name is 3 bromo 2 methyl but 1 in. This is also the salt example. This is also the salt example. This only we have to write in your notebook. Write the structures of the following compounds: 2-chloro, 3-methyl pentene. These structures we have to draw in your notebook. Now this part will be asked for the board examination. Methods of preparation of alkyl halides. First one, from alcohol. How you can prepare the alkyl halides? By using alcohols. Anyone can tell me what is the functional group of alcohols?
OH.
OH.
Sir, OH.
Only OH, na? AROH,
Yes, sir.
what is AROH?
ROH. ROH. Sir. R single bond OH.
And what is
AROH phenol है sir.
Yes, very good. AROH it will be phenol and ROH will be the alcohols. So if alcohols are given to you and if you have to convert into alkyl halides, which group will be replaced? Tell me. Alcohols are given to you. Suppose this one is ROH, correct? Just you told me the functional group of alcohol is ROH.
OH group will be
Replace, correct. Means this ROH we have to convert into which group? R?
RX.
X, correct. RX. RX means totally we have to remove this OH. So in the preparation of alkyl halides by using alcohols, this OH is replaced with X, remember. OH group will be replaced with X. Now see, many types of alcohols, variety of alkyl halides we can prepare. If the alcohols are changed, then the alkyl halides will be changed. If you are using primary alcohols, we will get the primary alkyl halides. If you are using the secondary alcohols, you will get the secondary alkyl halides. If you are using the starting material as tertiary alcohols, you will get the product tertiary alkyl halides. So variety of alkyl halides can be prepared by various alcohols by the replacement of hydroxyl group. This OH group we have to replace with X, that is halogen atom. So the replacement of this OH can be done by these 3 methods. First one, by using the halogen acids HX, in which HCl, HBr, HI, these are called as halogen acid. This is the first method. Second method is by using phosphorus halides. And third method is by using thionyl or sulfonyl chlorides, SOCl2. So one by one we will discuss the methods. First method is by using halogen acids, by using halogen halide, or it is also called as halogen acids. So the halogen acids reacts with alcohols to give different alkyl halides and water. Order of reactivity of alcohols: first tertiary alcohols will react very fast, then secondary alcohols react, and lastly primary alcohols. This is the general reaction is given. ROH, it is alcohol, plus HX, halogen halides, or it is also called as hydrogen halide. Suitable conditions we are using. This is the general reaction. So we get here the mixture of alkyl halide and water will be eliminated. So one by one we will take the examples how the alkyl chlorides are prepared. For the preparation of alkyl chlorides, first alcohol we have to take the alcohol plus HCl. Here we have to use one catalyst, that is anhydrous zinc chloride. This combination of HCl and anhydrous zinc chloride is called as Lucas reagent. Remember the name of the reagent is Lucas reagent. So it is mentioned alkyl chlorides are prepared by reacting alcohols. We are taking the alcohols plus Lucas reagent. Lucas reagent is the combination of
सर अनहायड्रस म्हणजे काय सर?
anhydrous म्हणजे water नसतं त्याच्यात. Water will be removed. It is totally water free. It is called as anhydrous. Just like anhydrous AlCl3. Anhydrous
Okay, sir.
means no water, remember. It is purely powdered form. No water. So the mixture of concentrated HCl plus anhydrous ZnCl2, this combination is called as Lucas reagent, remember. Many times for the CET board examination also, this question can be asked for 1 mark. What is Lucas reagent? Only we have to write it is the mixture of concentrated HCl and anhydrous zinc chloride. So by using this combination, this OH will be removed. OH will be removed. It will be replaced by this Cl. So this OH will combine with this hydrogen, and we get the water molecule. This is very easy and simple reaction. It is also called as Gru's process. Remember, this name is not used in your textbook, but in NCRT textbook or different textbook, this Gru's process it is used. Remember, for the CET or NEET JE exams, what is Gru's process or explain Gru's process, such type of questions can be asked. But in your textbook, this name is not used, remember, Gru's process, but this reaction having the name Gru's process. One condition
सर
is
दुसऱ्या कोणत्या हॅलोजनच्या ह्याच्यात पण सेमच घ्यायचं का?
नाही
दुसऱ्या केस
नाही
मध्ये पण सेमच
नाही नाही नाही
रिएजंट का?
नाही घ्यायचे.
फक्त
मी
क्लोरीनच्या केस मध्ये.
फक्त क्लोरीन साठी आहे हे, ब्रोमीन साठी वेगळे आणि
हा.
आयोडीन साठी वेगळे. मी येणार आहे खाली, एक एक रिएक्शन आपण बघणार. ठीक
हा
आहे.
सर.
One condition is that for the preparation of primary and secondary here, for the preparation of primary and secondary alcohols, we are using the concentrated HCl here. Remember. But in case of tertiary alcohols, there is a not need of concentrated HCl. For the tertiary alcohols, readily reactor, sorry, for the tertiary alcohols, there is not need of catalyst. Anyone can tell me why the catalyst is not needed for the tertiary alcohols? One important condition
Reactive,
is
sir.
because it reacts very fast. Why it reacts very fast? Because when the OH group is removed, see, in case of tertiary alcohols, ते एक्झाम्पलच्या वेळेस मी सांगतो तुम्हाला. ओनली फॉर द प्रायमरी अँड सेकंडरी अल्कोहोल्स द ZnCl2 catalyst is required because the reactivity is very less. Primary alcohols and secondary alcohols reactivity is very less. That's why the catalyst is required. But for the tertiary alcohols, directly we can add the concentrated HCl in absence of ZnCl2. Catalyst is not required. So one example is given here: primary alcohol, ethyl alcohol plus HCl, ZnCl2, we get ethyl chloride plus water. Now I am giving the secondary alcohols, isopropyl alcohol plus HCl plus ZnCl2, we get isopropyl chloride. Only this OH is replaced with Cl here. See, only this OH is replaced with this Cl, and this hydrogen it will be combined, and we get here water molecule. But see the example of tertiary alcohol in which directly we can heat this tertiary alcohols. Because if the OH is removed first, this carbocation is formed. This carbocation is stabilized by this resonance. Sorry, not resonance, plus I effect. Plus I effect, that is a inductive effect. Electron donating inductive effect. This CH3 donates the electron to this carbon. This CH3 donates its electron to this carbon. So this carbon will be stabilized. That's why tertiary alcohols are most reactive, most stable. The carbocation is most stable, and in absence of catalyst it can react to give tertiary butyl chloride. This OH is replaced with this chlorine. कळालं का
सर
रिएक्शन?
याला हिट करायची गरज नसते ना सर?
हीट केलं तरी चालतं, नाही केलं तरी चालतं, तरी रिॲक्शन होती. एक थोडंसं लिटिल हीट करायचं,
वॉर्म करायचं का?
हा, नुसतं वॉर्म करायचं. मोस्ट ऑफ द रिॲक्शन्स आर कॅरीड आउट विथ द हेल्प ऑफ हिटिंग. म्हणजे असं बॉईल करायची काही गरज नाही, जस्ट फ्लेमवर पकडलं की ती रिॲक्शन होते, म्हणजे OHचं कन्व्हर्जन लगेच Cl मध्ये होतं. ठीक आहे. नाव आय एम कमिंग टू द अल्किल ब्रोमाइड्स. कोणीतरी विचारलं होतं मला की सगळ्यांना कंडिशन सेम आहेत का, तर नाही आहेत. फॉर द प्रिपरेशन ऑफ अल्किल ब्रोमाइड्स वी हॅव टू यूज दिस NaBr प्लस H2SO4 बिकॉज जसं आपण HCl directly we can add the HCl, we cannot add HBr because HBr cannot be stored in the bottles. At that reaction time it creates, it is prepared at the reaction time. NaBr and the sodium bromide and H2SO4 reacts at that instant. HBr is prepared and that HBr reacts with the alcohol and we get here RBr. So the note is written here: alkyl bromides are prepared by heating alcohols with concentrated hydrobromic acid. This is a hydrobromic acid, or it is also called as hydrogen bromide. But this hydrogen bromide, it is prepared in situ. In situ means produced in the reaction mixture by treating NaBr and H2SO4. When this NaBr and H2SO4 reacts together, HBr is prepared, and then this HBr reacts with this alcohol, and rest of the process we know already. OH will be replaced with bromine and water molecule will be released. Again, one example is given here: ethyl alcohol plus HBr. But this condition is very important. If you forgot to write this condition, you will lose your half mark, remember. Because without this sodium bromide and H2SO4, we cannot prepare HBr. So this condition is very important. If you are writing HBr here, this condition is very must. One note is given: for the secondary and tertiary alcohols, dilute H2SO4 is used instead of concentrated H2SO4. For the secondary and tertiary alcohols, dilute H2SO4 is used, and for
सर
the
ते रिफ्लेक्स म्हणजे काय असतं?
बॉईल करायचं. रिफ्लक्स म्हणजे बॉईल करायचं 1 तास 2 तास 3 तास, वॉट एव्हर द कंडिशन्स आर देअर. म्हणजे काही रिॲक्शन 5 मिनिटामध्ये बॉईल केलं तरी होतं, काही रिॲक्शनला आपल्याला 24 hours बॉईल करावं लागतं, काही रिॲक्शनला 2 days बॉईल करावं लागतं. सो दॅट विल डिपेंड अपॉन द रिॲक्शन कंडिशन्स. सायंटिस्ट ऑलरेडी स्टडीड ऑल दीज रिॲक्शंस अँड रिॲक्शन टाइम इज ऑलरेडी गिवन. कितना रिफ्लेक्स करना है मीन्स बॉईल करना है दैट मिक्सचर, then we will get the product. So again here one condition is there: for the primary alcohols we are using concentrated HCl, but concentrated HCl use करने की जरूरत नहीं है for the secondary and tertiary alcohols. ठीक है, this is the main difference. If it is used, what will happen? जर सेकंडरी अँड टर्शियरी अल्कोहोलला आपण जर वापरलं तर त्याचं काय होतं बघा, खाली एक रिॲक्शन दिलेली. इट विल डिहायड्रेट दीज अल्कोहोल्स इंटू अल्किन. कसं डिहायड्रेशन होईल ते सांगतो मी. हां, सी हियर. आता इथे कुठं कॉन्सन्ट्रेटेड आणि डायल्यूट वर्ड इट इज नॉट यूज्ड इन दिस रिॲक्शन, बट if you are writing in the wording form, you have to use here if the secondary alcohols when these are heated with dilute hydrobromic acid. See here it is written ethyl alcohol on reaction with hydrogen bromide forms ethyl chloride. Here for the primary alcohols we are using concentrated HCl, but for the secondary alcohols we have to mention here here this H2SO4, it is dilute H2SO4, but here in case of primary this H2SO4 is concentrated. Instead of this dilute H2SO4, concentrated H2SO4 is used. कोणाचं तरी सुरू झालं माईक. व्हॉट विल हॅपन, आता ते सांगतो मी तुम्हाला. इथे जर कॉन्सन्ट्रेटेड H2SO4 वापरलं तर काय होतं? दिस इज नॉट, this reaction is not given. Only in this reaction isopropyl alcohol plus HBr, it gives the isopropyl bromide. अल्किन कसं फॉर्म होतं ते दिलंय का? नाही दिलं. हां, मी दाखवतो तुम्हाला. सी, suppose tell me the name of this alcohol. CH3 CH. Okay. प्लस
सर सेकंडरी कंपाऊंड जास्त रिएक्टिव्ह असतात म्हणून वापरतोय का आपण डायल्युटेड?
सेकंडरी आणि टर्शरी पण जास्त रिॲक्टिव्ह असतात, लक्षात घ्या. कारण हा जो रिमूव्ह करतो ना आपण इथला OH, पहिल्यांदा काय होतं का हा H प्लस असतो ना ऍसिडचा, हा OH ला रिमूव्ह करतो H2, मग इथं कार्बोकॅटाईन तयार होतं, लक्षात घ्या. इथं कार्बोकॅटाईन तयार होतो. आता इथे मी काय वापरतोय, कॉन्सन्ट्रेटेड वापरतोय. कॉन्सन्ट्रेटेड जर वापरलं, हा म्हणजे इथला हायड्रोजन आणि इथला OH रिमूव्ह होतो आणि इथं अल्किन मिळतो असा. CH3 इथे होईल CH, हा हायड्रोजन तसंच राहतो वरचा, इथे डबल बॉन्ड येतो CH2. हे कधी होईल जर तुम्ही इथे H2SO4 जर कॉन्सन्ट्रेटेड वापरलं तर, फॉर सेकंडरी and tertiary alcohols, if we are using here concentrated H2SO4. If the dilute H2SO4 is used, then the reaction will be, we get here bromine, OH will be replaced. See the difference between the products. This is dilute H2SO4 and this is this product is by using the concentrated H2SO4. We get alkene here instead of halides. कळलं काय? हे खूप महत्वाचं
हो
आहे.
सर.
कंडिशन्स बघायच्या. हा हा
परत एकदा सांगता का सर?
हा परत एकदा सांगतो. फॉर द प्रायमरी अल्कोहोल्स वी आर युजिंग कॉन्सन्ट्रेटेड H2SO4, करेक्ट?
येस सर.
इथे बघ, इथं प्रायमरी अल्कोहोल आहे. इथाइल अल्कोहोल इज अ प्रायमरी अल्कोहोल. हियर HBr it is prepared by using NaBr and H2SO4. But in this condition H2SO4 is concentrated for the primary alcohols. हा तेच जर कॉन्सन्ट्रेटेड आपण जर सेकंडरीला वापरलं तर काय होतं की इथे आपल्याला ब्रोमीन मिळण्याच्या ऐवजी काय मिळतो, अल्किन मिळतो. का अल्किन मिळतो? कारण इथं डिहायड्रेशन रिएक्शन होते. लक्षात घ्या, वॉटर मॉलिक्युलच रिमूव्ह होतो डायरेक्ट. OH रिप्लेस करण्याच्या ऐवजी वॉटर मॉलिक्युल रिमूव्ह होतो अँड वी डिडंट गेट द आयसोप्रोपिल ब्रोमाइड. त्याचं मी इथं मेकॅनिझम दाखवले तुम्हाला. हो का, इथे इथं पहिल्यांदा आपण काय घेतलं होतं, आयसोप्रोपिल अल्कोहोल घेतलं होतं आणि हा हायड्रोजन आणि हा OH जातो म्हणजे हा CH2 होतो. इथे प्रोडक्टमध्ये दाखवलं आहे. हे करून बघा तुम्ही, डिहायड्रेशन कसं होतं. हा OH आणि इथला हायड्रोजन रिमूव्ह
तर
होतो.
असं टर्शरीच्या याच्यात आपण जर कॉन्सन्ट्रेटेड वापरलं तर आपल्याला ट्रिपल बॉन्ड प्रोडक्ट मिळेल ना?
नाही, तिथं पण डबल बॉन्डच होईल ना, का सांगतो. इथे बघा, इथेच एक्झाम्पल आहे आपलं, इथेच एक्झाम्पल आहे ना वरती. हा म्हणजे
येस सर.
इथला हायड्रोजन जाईल, बरोबर, इथला हायड्रोजन जाईल, इथला OH, इथं कुठेतरी डबल बॉन्ड येईल, इथे येईल, इथे येईल किंवा इथे येईल. कळलं? म्हणजे प्रोडक्ट असा येईल. याचा प्रोडक्ट दाखवतो मी. असा होईल CH3 ॲज इट इज, एखादा CH3 ॲज इट इज राहील, 2 CH3 ॲज इट इज राहतील आणि एकाच CH3 म्हटला हा पण असाच येईल CH3 ॲज इट इज. हा आता इथले डबल बॉन्ड येईल आणि इथे येईल CH2. म्हणजे इफ दिस कार्बन इज कन्सिडर, इकडचा एक हायड्रोजन गेला आणि इथला OH, म्हणजे इथे डबल बॉन्ड येईल. कळलं का? हा प्रोडक्ट येईल जर कॉन्सन्ट्रेटेड H2SO4 वापरलं तर. कळलं? हे टर्शरीचं आणि हे सेकंडरीचं. ह्या गोष्टी खूप महत्वाच्या आहेत. या पुस्तकामध्ये कुठंतरी एका लाईन मध्ये दिलेलं असतं आणि त्याच्यावर एवढे भरमसाठ क्वेश्चन विचारतात ना. इथे बघा, एकच नोट दिलेली, एवढ्या नोटवर खूप प्रश्न विचारता येतात. फॉर सेकंडरी अँड टर्शरी अल्कोहोल्स डायल्यूट H2SO4 इज used instead of concentrated H2SO4 as it will dehydrate these alcohols into alkene. आता एवढ्या सेंटेन्सवर एवढे प्रश्न तयार करता येतात की मुलं हे नोट निग्लेक्ट करतात. तर असं काही करू नका. मी जेवढं सांगतो तेवढं फक्त लक्षात ठेवा. तर परीक्षेला कसं विचारतात हे आम्हाला माहिती. For the preparation of iodides now, I am coming to the alkyl iodides. Chlorides are prepared by using Lucas reagent. Lucas reagent is the combination of mixture of concentrated HCl and anhydrous ZnCl2. प्राइमरी एंड सेकेंडरी ला आपल्याला ZnCO वापरावं लागतं. टर्शियरी अल्कोहोल्स को यूज करने की जरूरत नहीं है, because already the carbocation will be stable and the reactivity of the tertiary alcohol is very high. Now, for the preparation of alkyl bromides, tell me which conditions are used. For the preparation of alkyl halides by using alcohols, the conditions are we are using HBr, and this HBr is prepared by using this combination NaBr and H2SO4. For the primary and secondary alcohols, we are using which H2SO4? Sorry, for the primary only we are using,
Concentrate.
yes, and for the secondary and tertiary we are using dilute H2SO4.
Dilute.
Now for the alkyl iodides, see the conditions. आपल्याला इथे HI वापरावं लागेल ना, HI, hydrogen iodide. Alkyl iodides are prepared by heating alcohols with sodium or potassium iodide. इथे बघा लिहिलंय sodium iodide, and instead of the sodium iodide we can use potassium iodide and H3PO4. H3PO4 is phosphoric acid. Here also HI is generated in situ. Means if this sodium iodide and this phosphoric acid reacts, then at that reaction condition HI will be generated. This HI will react with this alcohol. Again the OH will be replaced with iodine and we get here iodides. आता एक क्वेश्चन इथे बोर्डाला विचारतात नेहमी. In this reaction, phosphoric acid is used instead of concentrated H2SO4. कारण इथं रिएक्शन मध्ये आपण काय वापरलं होतं, H2SO4 वापरलं होतं, बरोबर नाही, इथल्या ब्रोमिनच्या. बट इन दिस आयोडीन रिएक्शन वी आर युझिंग द फॉस्फोरिक ऍसिड. वाय असं का वापरतात, तर त्याचं आन्सर इथं दिलेलं आहे. बिकॉज H2SO4 हा कोण आहे, H2SO4 इज अन ऑक्सिडायझिंग एजंट. हा ऑक्सिडायझिंग एजंट. आणि HI कोण आहे, HI इज द स्ट्रॉंग रिड्युसिंग एजंट. मग जर आपण H2SO4 वापरलं तर HI तयार होईल, पण हा HI काय करेल, HI रिड्युसेस द सल्फ्युरिक ऍसिड. लक्षात घ्या, हा तयार झालेलं हायड्रोजन आयोडाइड काय करेल, इट विल रिड्युसेस द सल्फ्युरिक ऍसिड टू सल्फर डायऑक्साइड and itself get oxidized to iodine. So to avoid these products we are using H3PO4. कळालं का? Why we are using phosphoric acid instead of sulfuric acid? Because HI is reducing agent, H2SO4 is oxidizing agent. So HI will react with the sulfuric acid to sulfur dioxide and itself get oxidized to iodine. To avoid this reaction, we are using here phosphoric acid. Remember, this can be also asked for the examination. For the preparation of alkyl iodides by using alcohols instead of H2SO4, why phosphoric acid is used? तो उसका आंसर आपको पता होना चाहिए. इसका आंसर यहाँ पे दिया है. So the preparation of here alkyl chlorides, alkyl bromides and alkyl iodides is completed. The first part is completed. Now the second B part is by using phosphorus halides. Phosphorus form two types of phosphorus halides. First one is PX3 and PCl5 only. PCl5, it is only phosphorus pentachloride. The phosphorus pentabromide is not stable. So remember, only one halide, that is phosphorus pentachloride, but for the trihalides it is PCl3 is also stable, Pi3 is also stable. Reaction with phosphorus trihalides, PX3 here. PX3, there are two halides, PCl3, PBr3 is also stable. The reactions are same. Alkyl chlorides are prepared by refluxing alcohols with PCl3. First, we will discuss the reaction with PCl3. Remember, for the PCl3, we are using here 3 molecules of alcohol. So here, How many chlorines are there? Tell me. 3 chlorines are there and 1 phosphorus is there. So this 3 OH will be replaced, will be 3 OH निघून जातील आणि त्याच्या जागी 3 क्लोरीन लागतील. मग शिल्लक काय राहिलं? What is remaining? 3 hydrogens. Then 3 oxygens are also there. 3 hydrogens are there, 3 oxygens are there, and 1 phosphorus is there. So it will combine to form H3PO3. That is a phosphorus acid will be prepared. And this OH will be replaced. 3 OH will be replaced. These 3 chlorines. So 3 hydrogens, 3 oxygens, and 1 phosphorus. It will combine to form H3PO3. It is called as phosphorus acid.
सर परत सांगा ना सर, नाही कळलं ती रिएक्शन.
For the preparation of chlorides by using PCl3. Here we are using only the 3 molecules of ethyl alcohol. These 3 chlorines, these 3 OH groups will be replaced, correct? How many OH groups will be replaced? 3 OH groups, because 3 molecules are there. 3 OH groups are replaced means how many hydrogens are there? 3 hydrogens are there, 3 oxygens are there, and 1 phosphorus is there. 1 phosphorus is there. These 3 chlorines, these are replaced. OH is removed. How many OH are removed? 3 OH are removed. 3 OH are removed means 3 hydrogens are there, 3 oxygens are there, and 1 phosphorus is there. So this combines together and we will get this byproduct. This is the byproduct. Phosphorus acid is the byproduct. H3PO3. See, H3PO3, this is the byproduct. 1 minute is remaining. So, हे कळालं का आता?
येस सर.
हा, हे
सर
रिएक्शन
ते ट्रायक्लोराइड आहे ना, म्हणजे PCl3. मग इकडे इथाइल क्लोराइड अल्कोहोलला 3 मॉलिक्युलच का घेतले? असं का असतं? 4 का नाही घेऊ शकत?
कुठे? काय परत विचार मला.
म्हणजे आता फॉस्फरस ट्रायक्लोराइड म्हणजे PCl3 ना, आणि इथाइल अल्कोहोलला 3 मॉलिक्युल घेतले.
3 क्लोरीन काढायचे ना आपल्याला. 3 काढायचेत ना क्लोरीन. 3 क्लोरीन आपल्याला रिप्लेस करायचेत का नाही? बरोबर आहे का नाही?
हो.
हा, मग 3 क्लोरीन रिप्लेस करायचे म्हणून 3 मॉलिक्युल घेतले अल्कोहोलचे. आता तुम्ही म्हणाल जर PCl5 असेल तर 5 घेणार का?